Hello students. So in today's session we'll be seeing about capacitance and we have already seen about capacitance. So try to know whatever we discussed in the previous session is very basic. So I want to come up with some new questions so that you actually are trying to solve problems even slightly. I'll be touching from JEE Mains. We have already covered NEET level. Yes, we have already covered the basic concept, but slightly JEE Mains or even JEE Advanced level. Let us see some problems based on that, and also we will try to see some previous year's questions based on JEE Advanced for this session. So this entire video is based on that only, right? So let us see one question. Let's say there is parallel plate capacitor. Till now we have seen if there are two parallel plate capacitors kept like this, right? If there are two parallel plate capacitors kept like this, what is capacitance? If this area is given as A, right, this area is given as A, what is the capacitance we have seen, correct Amma? So what is the capacitance when this is there? Epsilon naught A by D. This is what we have seen in the previous session. But now let us see little different question. What is the question here? So in this, let me take, there is a parallel plate like this, right? We are trying to see a parallel plate like this. On the top of it, we have a parallel plate, and also on the bottom, parallel plate is kept at an angle theta. Parallel plate is kept at an angle. The top plate is kept at an angle theta, but the bottom plate is going to remain same as this. But top plate is inclined at an angle, so this total distance is given as 2y naught. This distance between the plate is given as y naught. So we need to find what is the capacitance between the two parallel plates when they are placed at an angle theta. Very simple one. Is it going to be same epsilon naught A by D? Is it going to be same epsilon naught A by D as this? No. Because here when we are trying to take the distance here is varying from y naught to 2y naught. Correct or not? There is a distance here which is varying here. So for kind of like doing these kind of problems, always we must do what? Choose an element at a distance x, then find out what is going to be capacitance of the small element and then integrate it. Right, ma'am? So here we will take at a distance x, right? There is a small element that we are trying to take of small element of thickness or this length of dx here. We need to find what is going to be the capacitance of this small element. How do you find that? Here this distance is y naught. Let us take this distance here. At distance x here we are taking this as y1. So this is a very small element. At that small element this dx is very small. So this distance we are taking it as y. So when you are trying to take this angle is theta, right? This angle is going to be y1. This is going to be x here. This total distance, right? They will give us this as a here, this width as b. The same thing here. This is a here. The width of the plate here is going to be b here. So this is going to be a, right? The distance is going to be a, and this height is going to be what, y naught. The total height I am trying to talk about, because the total a, and at this point we have y1, right, ma? So now how do we find what is the capacitance of this small element that we are trying to choose? So we will consider that as dc, and dc is what, ma? Epsilon naught a by d. What is a here, ma? What is a here, ma? A here is this small elemental area. This is b here. This is dx. So b into dx is the area, the small elemental area. Epsilon naught a by distance between the plates. What is the distance between the plates now? Y naught plus y1. Distance here is going to be what, ma? Y naught plus y1. Now think about it. How do we find what is going to be the equivalent capacitance when we are trying to take this Y naught? It is varying from Y naught to 2Y naught, right? So here let us try to take the small DC here, and if you are integrating it, we get the total capacitance. So epsilon naught dA here is what? D into dx by d here is what? Y naught plus y1. And if you're trying to look at these equations that we have here, we can write tan theta. What is tan theta here, ma? Y1 by x is equal to what? Y naught by a. Correct or not? So what we can write this y1 as? Y1 we can write this as y naught a into x. Correct or not? So here if you are trying to substitute all these in this integration and integrating from x is varying from where to where, ma? Here dx is there. Whenever dx is there, we have to choose this element, and here we will try to have 0 to a. This dx is varying from, this element is varying from 0 to a. So here we will try to take integral of epsilon b dx divided by y naught plus y1. What is y1 here? Y1 is y naught a into x. So here we will take the same limit 0 to a. Epsilon b here is a constant, right? Y naught is also a constant. So in this, all these can be taken outside of the integration. Epsilon b by y naught. What is variable here, ma? X is variable. So integral of, right? Integral of, what is the remaining that we get, ma? Y naught taken common, we get 1 plus x by a, and we will have integral of dx by 1 plus x by a is what we get. Correct or not, ma? So here y naught is a constant, dx is a variable, only x is a variable. All the things are constant. Correct or not, ma? So taking the limits from 0 to a. Now what is integral dx by 1 plus x, ma? Integral dx by x, we know it is ln x. So same thing we will try to take. But here there is 1 by a. So by chain rule, what we chain rule, like in differentiation we multiply, but integration we will try to divide with that. So what is going to be the equation that we get here, ma? Epsilon b y naught integral of dx by 1 plus x by a is going to be ln of, right, ln of 1 plus x by a, right? We have to take limits, and now we have to differentiate this, right? We have to differentiate this. We get 1 by a, and that 1 by a we should be writing it here. That is how we have to do integration. Whenever we have dx by 1 plus a x, it is going to be what, ma? Ln 1 plus x by a we will write. But here 1 by a is there, so we will write 1 by a in this case. So ln of 1 by 1 plus x by a, and we have to take limits 0 to a, ma. 0 to a, when you are trying to substitute 1 plus upper limit 1 plus a by a minus lower limit 0 if you are trying to substitute, because x is varying from 0 to a. So what is going to be the expression that we get here, ma? Epsilon naught ab by y naught into ln of 1 plus a by a, right, which is 1 plus 1, that will be ln 2 minus ln 1 plus 0 by a, ln 1. So what is that we get here, ma? Ln 2 minus ln 1. Ln 1 is 0 here, so ln 2 alone we get. So what will be the final result for this, ma? Epsilon ab by y naught into ln 2. Clear with this idea here, ma? So try to know, this is a very simple concept, but here we are trying to deal with a parallel plate capacitor. A here, when it is kept epsilon naught AB by D, right? But whenever we are having this, what is happening to this? Epsilon naught AB by Y naught into ln 2 we are getting it. Clear with this idea here. So I want you guys to focus on this very important concept. When our angle is changing, things will change. Now we will try to see in terms of how medium changes things. Right now, next topic that we will try to see here is about when medium is placed, how capacitance is going to change. Right? When a medium is placed, how capacitance will change. We have seen this whenever dielectric medium is placed, what is going to happen to the equivalent capacitance. So if I am trying to place a dielectric medium of K here, which is having capacitance C here, C is equal to what now? Epsilon A by D. This is whenever free space is there. But when a medium is kept, what is going to be Cm here? Epsilon M into A by D. And what is relative permittivity, ma? Dielectric constant or relative permittivity is what? Permittivity of a medium by permittivity of a free space, where K is a dielectric medium place. So permittivity of medium is what? Epsilon R into epsilon naught. So here capacitance in the medium, EM we can write it as ER into epsilon naught A by D. So what is happening here in the medium? It increases by relative permittivity time. So we can also write this ER is nothing but this dielectric constant, which we can write as epsilon naught A by D. So now if there are two or more dielectric constant placed between the parallel plate capacitor, how we gonna deal with these kind of problems also, we'll be seeing it now. So here it's very simple, ma. If you understand it is going to be important for both NEET, JEE Mains, even JEE Advanced. We will be seeing few questions based on JEE Advanced as well in today's session. But I'll first try to talk about the theory topic, and then we will go with mains and advanced level problems. Right, ma? So we'll be seeing how series when mediums are placed. Series when mediums are placed. Series means what? Dielectric mediums are placed like this: K1, K2, K3 and K4 and so on. We can have infinite dielectric mediums, right? Let me take K4 and K5 as well. Right now, so all these are similar to series connection of parallel plate capacitor. But try to know here, if this is total distance D, here area is not changing for all these dielectric mediums. For all these dielectric mediums, area of this is completely covered between the parallel plates, but distance is changing. So let us take that this is D1, this is D2, this is D3, this is D4, this is D5 here. So how do you find equivalent capacitance in series connection? 1 by C equivalent in series is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus 1 by C5. We have 5 equal capacitances. Now these 5 are connected in series. So here we will try to take 5 capacitors, 3, 4 and 5. 5 capacitors connected in series. So where C1 is going to be what? Medium is K1 epsilon naught A. Distance is going to be the new distance, is D1. So K1 epsilon naught A by D1 is going to be what, ma? C1, where C2 is going to be what? K2 epsilon naught A by D2, where C3 is going to be what, ma? Let's say C3 is, I'll try to take a different color. C3 is what? K3 epsilon naught A by D3, where C4 is what? K4 epsilon naught A by D4, where C5 is what, ma? K5 epsilon naught A by D5. So here 1 by C equivalent, we can write it as 1 by C equivalent in series. We can write this as 1 by C1. 1 by C1 is 1 by K1 epsilon naught A by D1 plus 1 by K2 epsilon naught A by D2 plus 1 by K3 epsilon naught A by D3 plus 1 by K4 epsilon naught A by D4 and so on. 1 by K5 epsilon naught A by D5. So I hope you guys are getting this. Now 1 by C equivalent, how do we write it, ma? 1 by C equivalent, how do we write it? 1 by C equivalent in series, we can write all these epsilon naught a's are constants here. So 1 by epsilon naught a we can try to take common, and what is going to be there, ma? 1 by this is going to be k1 by d1 plus 1 by k2 by d2 plus so on to 1 by k5 by d5. So if you are trying to take C equivalent here, what is going to be C equivalent in series? So all these, if you are trying to cross multiply this, C equivalent C epsilon naught A will be going in the top divided by, right? So in this d1 by, this is going to be what, ma? d1 by k1, we can write this as d1 by k1, this one d2 by k2, this one we can write as d5 by k5. So if you are trying to take this into denominator here, we get d1 by k1 plus d2 by k2 plus so on to d5 by k5. So that is going to be the epsilon naught, and sometimes they will ask us what is going to be the equivalent dielectric medium. Equivalent dielectric medium means we write this as K equivalent into epsilon naught A by D. So and we have to equate this D1, sometimes they will say it is equally divided, then D is going to be D by 5, then K equivalent we have to get by equating these two. Clear with this idea here, ma? So like this we have to find out dielectric medium, and you can remember this expression whenever series law, right? Whenever slabs are placed parallel to the parallel plate capacitors, then what is going to happen? C equivalent is going to be epsilon naught A by d1 by k1 plus d2 by k2 plus so on to d5 by k5 or dn by kn. We can try to write it and try to find out equivalent capacitance. If they are asking, we have to write that is replaced by k equivalent and find out what is going to be k equivalent. Similar to what we have done in series and parallel connections of capacitors. So in a series connection, T1, sometimes they will give instead of D1, we have to take T1 by K1, T2 by K2, so on to T5 by K5. Like this, we can try to take and try to get the expression for C equivalent of the capacitance. Let us see about parallel connection of capacitors. So in a parallel connection, parallel connection basically means when here the area is going to be divided. Area of the plates, because the slabs are placed perpendicular to the parallel plate capacitor. So here we will have different slabs placed like this, right, ma? So that is going to be having K1. Let me take that. This is going to be K2 here. So like this we have. Let me not draw this, right? K2, and there is going to be K3. Let's say there are three different mediums that we are taking here. So this thickness is going to be T1, this is T2, this is, or let's say this is X1, X2 and X3, right, ma? So here we get area of this cross section is going to be what, ma? This is what, let's say this is B here. Area 1 is going to be Bx1. Area 2 is going to be what? Bx2. Area of 3 is going to be what? Bx3. And that case, the distance between all these should be remaining same. So this can be replaced by a combination, right? How do you write it, ma? There are three mediums, three capacitors connected in a parallel. So here this is going to be having a K1, K2 and K3. How do we write this C1 here, ma? K1 epsilon naught A1 by distance is going to be same, where C2 we can write it as K2 epsilon naught A2 by D. C3 we can write this as K3 epsilon naught A3 by D here. So in all these cases epsilon naught A1 by D. So here A1 is going to be B into X1. Sometimes they will say that X1 is equal to X2 is equal to X3. In that case, A1 is A by 3, A2 is A by 3, A3 is A by 3. But if it is different, let us see how to do it. We know that 1 by C equivalent in parallel is going to be what, ma? C1 plus C2 plus C3. What is C1 here? K1 epsilon naught A1 by D plus K2 epsilon naught A2 by D plus K3 epsilon naught A by D. So here what we can take constant here, ma? Epsilon by D is common. So we get K1 A1 plus K2 A2 plus K3 A3 so on to Kn An. So that is going to be C equivalent in parallel connection. Clear this idea here, ma? So it is very important to know how do we take whenever medium dielectric slabs or the medium is introduced here. How do we take series and parallel connection? Whenever parallel plate capacitors parallelly, if you are placing slabs, C equivalent we have to take it as series connection, and whenever dielectric slabs, two parallel plates are there, now we are connecting like a medium is connected between this. So this is perpendicular to these dielectric slab, that is what is parallel. Like this there are three parallel plates placed. So for that we have to take, this is going to be the final result where C equivalent series is going to be what, ma? Epsilon naught A by D1 by K1 plus D2 by K2 plus so on to Dn by Kn. We have to take these two results. These two results are very, very important. Sometimes there will be mixed combinations of series and parallel. If mixed combinations are there, because in JEE Mains or even JEE Advanced or even in NEET, they can ask you questions based on this. So mixed capacitance are there means how do we find these things? We will try to see those questions as well. So we'll be seeing this PYQ question which is asked in 2000. It's long back, but yes, this was, we can say it is JEE Mains or even NEET level as well, right? So here they had given equivalent capacitor, like across AB we have to find, right? If there are four different mediums, we need to find what is going to be the one dielectric medium which replaces all these dielectric slabs. 1K equivalent. What is going to be the equivalent dielectric constant only we have to find. So here in this question, how do we take, ma? If you are trying to see here across AB, these two are parallel and that is in series with K3. So here we will try to redraw the circuit here. There are two capacitors connected in parallel. So which is, this is C1, this is C2, this is C3. So this is C1, C2. Now this is in series with, right? This is between AB. This is in series with what, ma? Capacitor C3. So that's how we find equivalent capacitance across AB. So now if you are trying to take C equivalent across AB is going to be what, ma? C1 is in parallel with C2, right, and is in series with C3. So whenever series and parallel connections are there, we know how to solve the problem. Parallel means we replace this with plus, series means this into this plus this plus this. That's all is what we have to do here. So C1 plus C2. C1 here is what, ma? C1 plus C2. What is C1 here, ma? K1 epsilon naught. A here will become A by 2. D here will become D by 2. 2 get cancelled. So what is going to be C1 here, ma? K1 epsilon naught A by D. What is going to be C2? I think similar thing, right? A by 2. So C2 also is going to be same. K2 epsilon naught A by 2 by D by 2, that will be epsilon A by D. C3 is going to be what, ma? K3 epsilon naught area is going to be the total area because C3 is covering the entire plate, but distance is becoming D by 2, so that will be 2K3 epsilon naught A by D. So C1 is going to be what, ma? K1 epsilon naught A by D plus K2 epsilon naught A by D, right, ma? Is in series with C3 is going to be what, ma? K3, 2K3 epsilon naught A by D. So that will be the equivalent capacitance. But what they are asking here, we need to find one single dielectric constant which is having K equivalent is what we need to find. So that is what is asked in this question. So here epsilon naught A by D, we can take it common in all these cases. Epsilon naught A by D, if you are taking common, we get K1 plus K2 is in series with epsilon naught A by D into 2K3. So this into this by this plus this. So epsilon naught A by D into K1 plus K2 into C2 here is epsilon naught A by D into 2K3 divided by sum of these two epsilon naught A by D. Summing means epsilon naught A by D is going to be constant. So we get K1 plus K2. This is going to be constant. So plus 2K3 we get. So one of these epsilon naught A by D, one of this epsilon naught A by D is going to be cancelled, and C equivalent A across B, AB we can write as K equivalent into epsilon naught A by D. Epsilon naught A by D, this epsilon naught A by D can be cancelled. So what is going to be K equivalent in this mark? What is going to be K equivalent in this? We get K equivalent, we get it as K equivalent, we get it as K1 plus K2 plus 2K3 divided by K1 plus K2 plus 2K3. So sometimes they will ask us 1 by K equivalent. 1 by K equivalent is going to be what? K1 plus K2 into 2K3 this is correct. So 1 by K equivalent we can write this as 1 by K equivalent we can write this as K1 plus K2 plus 2K3 divided by K1 plus K2 into 2K3. So we can split this up. K1 plus K2 by K1 plus K2 into K1 plus K2 into 2K3 plus 2K3 divided by K1 plus K2 into 2K3. So 2K3 get cancelled, K1 plus K2 get cancelled. So what is going to be 1 by K equivalent of this mark? 1 by 2K3 plus 1 by K1 plus K2. So that is going to be the final result in terms of 1 by K equivalent if they are asking 1 by K equivalent, or K equivalent alone if they are asking. This is going to be the result. So options can be differently they can ask. So based on that we have to solve this question. This was asked in 2000 when JEE Advanced was not even introduced then. So probably you can consider this as JEE Mains level and NEET level also they can ask, because nowadays NEET level is almost equal to this JEE Mains or even Advanced level, some questions at least. Right, ma? So that's all about this question. I hope you guys understood this. This PYQ 2014 JEE Advanced question. So previous year questions we are trying to see only. So here advanced level question again. So in this we have charge Q1, Q2, there is a capacitor placed here, and there is a dielectric medium which was filled only till A by 3 mark. If this is A by 3 and the distance is given as D, E1 and E2 are the electric field in the region 1 and 2. So K1 is the dielectric medium, right? K1 is the dielectric medium. So this was, I think, more than one correct answer is what is given here. So there are few things that is given. If they are charged with the same source, charges stored on this is going to be Q1 and Q2 now. So what are the questions they are asking? So they had given this is going to be C1 capacitance, this is going to be C2 capacitance, C equivalent is given as C here, and we have to take the ratio of C by C1, C by C1 or C1 by C2, something like everything they would have given. So how do you find that? C equivalent here ma. Both these mediums, here there is a medium, here there is no medium. They are connected in series or parallel. They are connected in series or parallel. They are connected in parallel connection. So if you are trying to take this as C1, this is C2. C1 we can write as K1 epsilon naught A by 3 into D here is same. Where if this is A by 3, what will be this area here ma? 2A by 3 will be area. So what is going to be C2 here? K2 epsilon naught 2A by 3. Distance between them is going to be same. So as this is C equivalent, what is going to be C equivalent here ma? C1 plus C2. So what is C1 here? K1 epsilon naught A by 3D plus K2 epsilon naught 2A by 3D. So taking that epsilon naught A by 3D we can take it as common. We can write as K1 plus 2K2. Right, ma'am? K1 plus 2K2. So what is K2 here, ma'am? K2 here is 1 because free space is there, right? So K2 is going to be 1. So epsilon naught A by 3D into K1 plus 2 will be the C by expression. So they are asking what is going to be C by C1. C by C1 is going to be what, ma'am? Epsilon naught by C1. Epsilon naught A by 3D and K1 we have. So epsilon naught A by 3D will be cancelled. So what is that we get here, ma? K1 plus 2 by this K1, epsilon naught A by 3D will be cancelled. So that is going to be what, ma? K1 we will have. Right, ma? And if they are asking us to find out what is going to be the ratio of their electric fields. Electric field, will it be same or not? If they are connected with the same potential here, electric field is going to remain same irrespective of, why? Because electric field is taken as what, ma? V naught by D. Distance between them is same. So electric field is going to remain same. So E1 should be equal to E2. This is what we get. And now charges. How do you get charge in this, ma? Q1 and Q2, different charges. So Q1 we can write it as C1 into V. Q2 we can write as C2 into V. What is going to be Q1 in this, ma? Both are connected to the same potential. C1 here is what? K1 epsilon naught A by 3D. K1 epsilon naught A by 3D into V. Whereas C2 here is K2 is 1 here. So epsilon naught 2 into epsilon naught A by 3D into V. What is going to be ratio of this epsilon naught A by 3D? V get cancelled. So what is going to be ratio of Q1 by Q2 that we get here, ma'am? Ratio of Q1 by Q2 is going to be what, ma'am? K1 by 2. K1 by 2 will be the ratio of these two. Clear with this idea, ma? So this is very simple question. Again, this was asked in JEE Advanced, but this is simple only if you know the concept behind this. This again another advanced question based on 2015, again based on parallel plate capacitor, where medium is introduced. So in this question, ma, in this question they would have they had given this is how the arrangement is done, right? So dielectric constant E1 is given as 2, E2 is given as 4. C1 is capacitance when these two mediums are not introduced. So this entire thing is having E1, ma, right? This entire portion there is E1, only this portion is covered with E2. We need to find what is going to be the ratio of C2 by C1, where C1 is capacitance in air, C2 is capacitance after the mediums are introduced, right? So here, how do you find in this? See, in this case, we have two mediums which are connected in parallel, that is in series, and then that is in parallel with respect to this. Correct, Amma? So taking that, we will try to redraw them. Right, two of them are connected in series here. Right, so this is, we will take this as C1. C1, C2 are already taken. So let us take that this is C3, this is C4, and this is C5. So C3, C4 are in series, right? Charge remains same. Whereas C5 is in parallel to these two. So that is going to be C equivalent now. So what is going to be C3 here, ma? How do we write C3 here? Epsilon 1 into area is going to be, I think they have mentioned that area is going to be exactly half here. This distance is given as D by 2. Area is going to be A by 2 here. So epsilon 1 A by 2 by into epsilon naught. Epsilon 1 epsilon naught A by 2 divided by D by 2 is C3, and C4 here is going to be what, ma? C1 is epsilon naught A by D. This is when entire medium is filled only with air. C4 is what? It is filled with dielectric medium epsilon 2 epsilon naught A by 2 by D by 2. 2 get cancelled here. E1 is given as what, ma? 2 here. So 2 epsilon naught A by D. This is going to be what? 4 into epsilon naught A by D. Right, ma? And what is going to be C5 here? C5 is going to be covered with epsilon naught into area is going to be A by 2, but the total distance is going to be D here. The total distance is going to be D here. So what's going to be this value here, ma? 4, this is going to be epsilon 1 is 2. Epsilon naught 2 get cancelled, so I think we'll get only epsilon naught A by D, because this is 2, this is also 2, this get cancelled here. So these are three things will be there. So now C3 and C4 are in series, ma. Series le irukkrappo what is going to be C equivalent? C3 C4. C3 is in, so C equivalent is going to be, which is what we are trying to find here, is C2. So what is C2 here? C3 is in series with C4, and this in together parallel with C5. Parallel means you can directly substitute this with plus C3 into C4 by C3 plus C4. What is C3 here, ma? 2 epsilon naught A by D into C4 is what, ma? 4 epsilon naught A by D, right, divided by C1, C3 plus C4. C3 plus C4 is going to be 2 epsilon naught A by D plus 4 epsilon naught A by D plus C5 is what, ma? Epsilon naught A by D we get. So all these epsilon naught A by D, one of these can be cancelled by taking common, one of this will cancel. So we get epsilon naught A by D, 2 into 4, that will be 8 here, ma. 2 plus 4, that will be 6 here, ma. So all these will become, this will be, final result will become here, right? Final result will become 4 into 2, 8 by 4 plus 2, that will be 6 into epsilon naught A by D plus epsilon naught A by D. So here we have 4, here we can cancel them up, 4 by 3 epsilon naught A by D. So taking LCM we get into 3 into 3. So what will be this, ma? 4 epsilon naught A plus 3 epsilon naught A, that will become what, ma? 7 epsilon naught A by 3D. 7 epsilon naught A by 3D. What is that they are asking here? The ratio of C2 by C1. C2 is 7 by 3 epsilon naught A by D, and C1 is what, ma? Epsilon naught A by D. So what is going to be the ratio of these two, ma? C2 by C1 is going to be what, ma? 7 by 3 is what we get for this. Clear this idea here, ma? So I think this question is also like, yeah, they have asked in 2015 advanced, but yes, this is very basic. Like if you understood series and parallel connection, this kind of concept is going to be very easier, and even advanced level questions you can easily try to solve. Right, ma? That's mostly today we discussed about JEE level and JEE advanced level. Specifically, I have discussed very few questions. With whatever time we have discussed only those questions. But if at all you wanted me to discuss, there are specific questions, you can try to post it in comments so that I can try to share those, or I'll try to discuss those questions, right, ma'am? And also, if at all those who are preparing for NEET separately, I'll try to make some questions based on previous year mains and also NEET level questions. We'll be making a separate video for that as well. But feel free to post whatever that you wanted me to discuss, right, ma'am? And it's also important, whoever is preparing for JEE Mains or JEE Advanced or even NEET, do not get like worried about the exams are coming here. Feel free and try to concentrate on what is your strength and work on your weakness. So definitely that is going to be helping you and make things better. Right? Thank you guys, and I wish you guys all the very best for those who are preparing for NEET, JEE Mains or JEE Advanced. The first exam, I think JEEs have result, the applications have been released, so you have to definitely attempt them. So the first exam that you're going to write, most of the NEET students also will be writing JEE Mains. So I want you guys to be more confident and try to work on your strengths and try to concentrate more on your strength. Definitely, whenever time is there, work on your weakness as well. Thank you guys. I wish you guys all the very best.